Hope you can all hear me okay. It's very good to be back to the African Internet Summit, even though we're all sitting here online. I'd much rather be visiting you all in person, but in a way, given the current global situation, I think this is a pretty good alternative. So yes, I'm trying to follow the quiz with something a little bit more serious, and it was good to see some of the quiz questions actually coming up with some of the content I'm going to be talking about. So I want to have a look at, as Isabella said, just some aspects of routing policy and security globally. So just looking at some of the best practices. And Dawit, in his welcoming remarks, talked about the industry initiative called Manners, the mutually agreed norms for routing security, which I've put on the screen here as a summary, basically filtering eBGP sessions so that we prevent propagation of incorrect routing information, blocking traffic with spoofed source addresses, communication between network operators. And that's not just picking up the telephone and talking to another operator, but it's public information, for example, in the peering database, route objects, AS objects, and NOC contact details. And finally, the validation of routing information. And it's the last one that I want to spend more time on for this presentation. The first three, well, we've been doing for 20, 25 years for a lot of them. So the validation of routing information is probably one of the more important ones that is getting a lot of focus right now. So we're going to look at RPKI and the route origin authorization, which is basically a digital signature indicating the origin AS of an announced route. It's well established globally. This has been around for probably at least 7, 8, 9, 10 years, depending where you want to start counting. It's widely deployed these days. Certainly a lot of work in the last 2 years to get RPKI deployed widely across the internet. And more operators are signing ROAs every week. A typical ROA would look something like this. I'm not going to spend time looking at the mechanics of this. Each of the 5 regional internet registries has a mechanism for network operators to get the ROAs signed through the member portals. I'm going to look at this more from operational side. So a ROA would look something like I've shown on the screen. A prefix, a maximum subnet size, and which autonomous system is going to originate that prefix. An important thing to remember is that there can be more than one ROA per address block, which allows the operator to originate prefixes from more than one autonomous system. And that allows us to change or make changes in routing policy or prefix origin, just for operational needs. Where can you see ROAs? They're not these mysterious things that are hiding somewhere away on the internet. There are many places you can go and look. And one place you can look is RouteViews. RouteViews has been running since, mid-90s. And for many years, routers that you can simply log into, look at the state of the BGP table, and really check the connectivity of your network as viewed from many different places all around the world. There's more about RouteViews on the URL there, but recently, during last year, RouteViews added the capability of looking at the RPKI table. So you can jump onto the router. This is just the standard RouteViews, the Cisco router sitting at the University of Oregon in the US. And you can see both the V4 RPKI table and the V6 RPKI table with the simple commands highlighted in red there. So this was a snapshot I took a few days ago when I was finalizing these slides. You can also find them on Hurricane Electric's BGP page, the well-known bgp.he.net. And if you can pick an autonomous system, and the ones that you see there with the padlock, the green padlock, means that they have signed the ROA for this particular prefix. Um, to find out how global deployment has gone, the RIPE NCC has a useful page, certification stats, which shows various statistics that are shown in the graph here. So this shows you all the way back to 2011 about the uptake in how many operators have signed ROAs. So this shows really in the last year or last 18 months, the big uptake that we have seen in many parts of the world. Yellow is the RIPE NCC. Europe has been probably at the forefront of getting ROAs signed. But in the last, I would say last year, we've seen a big increase in folks getting ROAs signed in the ARAN and APNIC regions. We can look at the number of ROAs, we can look at the amount of IPv4 address space that's covered in ROAs. So again, we see big increase in ARAN's service region. We look at the V6 address space. Not a lot happening in V6 with getting ROAs signed. Europe, it goes onwards and upwards. The rest of the world, apart from a very recent uptick in ARAN region, not a lot really happening. Not quite sure why about that, but anyway, it's good to see upwards in both V4 and V6. So as I was saying, we're focusing on RPKI. So the next piece I want to look at is what's known as route origin validation, where the network operator checks if a ROA exists for the entry in the BGP table. If there's a valid entry, we allow the prefix. If it's an invalid, we drop it. If it's not found, well, these days folks are allowing it, but they're probably giving it a lower preference over a valid entry. So this is really the three states that we have with origin validation. And there are lots of operators deploying RPKI and ROV. I haven't tried to produce an exhaustive list here. These are just some of the operators just in my wandering around the internet, seeing what people are doing, seeing who's doing validation and so forth. It's not just the transit providers like Telia or NTT. It's also content providers, internet exchange points, research and education networks, and many access providers as well. So a lot of people are kind of quite afraid about going to deploy this. They think if they turn on validation, half the internet's going to disappear. Well, you don't have to just turn it on and just suddenly the world's a wonderful place for you. You can be a little bit cautious, take some careful steps just to see what's going on. First off, sign ROAs for originated address space. That has no negative operational impact. And add it to your standard operating procedure. People forget that second step. They originate it and then go to sleep and then forget. And when the changes to announcements happen, they end up with having invalids roaming around the internet. Add it to your standard operating procedure. If you're going to originate the prefix into the global table, sign it. And then things are simple. The next thing you can do then is observe what's going on. So deploy a validator cache. I'll look at that in a minute. Have your eBGP speaking routers talk with the cache, but don't implement any policy. Just be aware if you're using Cisco iOS or iOS XE, policy is implemented by default and you've got to actually turn it off. Have a look and see what the invalids are. Do they affect you or your customers? If your customers are causing invalids, work with your customers to fix those. Once you're happy with operations and you know it's not going to cause any issue, you're comfortable with how the validator cache is working, go for full deployment. It's a good idea to deploy redundant caches. If one goes away, you still want to be able to do validation. And implement ROV, drop invalids on all the eBGP speaking routers. Where do you see the invalid routes? Again, you can go to RouteViews. If you don't have your own cache and you don't have that feeding your own router, you can go to RouteViews. Here's an example, RouteViews 3, again at the University of Oregon, show IPBGP route map invalid. That's already been set up, so you can find all the invalids currently in the global table. There are lots of best practices for creating ROAs. It is really important not to create ROAs for unannounced subnets. In the early days of doing this, people got very excited and they created ROAs for not only their address block, but every single subnet down to the smallest possible one. So /32 for v4 and 128 for v6. The problem with this is you can end up with a validated hijack. Here's one I've put on the screen, a current RPKI ROA. Network 1.34/15, it's signed from 15 all the way to /24, but this is the only prefix in the BGP table. There are no subnets of 1.34/15, at least not in my view. So it means that an attacker can use AS3462, they just set up that on their router, originate any subnet of that /15, and they will be able to hijack that service to that address block. And I've drawn a picture about how this might actually work. And this is entirely feasible. So it's really important to make sure you never create ROAs for prefixes or subnets that are not announced to the internet. Back to what I said earlier about putting it in your standard operational practice. Only sign what you originate. There's also something called disavowal of routing origination. AS0 has been set aside so you can sign a ROA, a prefix with AS0 to indicate to the global internet that this prefix should never ever appear in the global system. Because if you're checking if they're valid or not, and there's AS0, well, if they're announced by another AS, they're going to be invalid. So what would we use this for? Could be internal use of a prefix that should not appear in the global BGP table. Internet exchange point LAN is probably a very obvious one, which should never appear in the global table. Perhaps private address space, non-global unicast space. For v6, unassigned address space, which is under discussion within the various regional internet registry policy fora. And v4 and v6 address resources, which should not appear in the global table. So these are possibilities. And for information, I'm sure several of you know, APNIC has now published its AS0 TAL, which is separate from the regular one. And I've shown some examples on the slide here of showing some prefixes that appear in the table today with AS0 as the origin AS ROA. There are many more than this. Of course, they can't fit onto this screen or even many screens, but I'm just giving you some idea of AS0 use today. What about implementations? For many years, it was, my vendor doesn't support, can't do it. These days, I mean, this is probably not an exhaustive list, but certainly the last time I was looking at implementations, all these vendors have RPKI implementations. They will support route origin validation, some better than others, and I'll leave the details for you to research by yourself, but certainly a lot of the mainstream ones that are in use today. What about validator caches? Well, the three most popular ones in order are NLNet Labs Routernator. It's probably the most widely used one today. LACNIC Mexico have a Fort validator, and then Cloudflare have their Octo RPKI. The nice thing with these three validators, they're all available as Debian Ubuntu.deb packages. So it's just an apt install, done. Much easier than even 2 years ago when we were compiling these up from scratch and trying to find libraries to make them work and so forth. Notice that the RIPE MCC validator is being discontinued as from the 1st of July. So any of you who are already using it, you might want to start looking for an alternative. There probably are other validator caches, but these are the most widely used ones today. So for design advice really is, I would deploy at least 2 validator caches, geographically diverse. Some folks are deploying 2 different implementations, really for software independence, in case one implementation has a bad day. Configure the validator to listen on both v4 and v6, and configure the routers to have both v4 and v6 connections as well. And of course, usual thing about securing the validator, so only your eBGP speaking routers have access to it. To deploy inside an autonomous system, eBGP speaking routers talk with the validator. Supporting ROV means you drop the invalids as they arrive from the network, and that's it. iBGP speaking routers do not need to talk with a validator because only the valid and not found prefixes are going to be distributed. The validation table is separate from the BGP table and it's not distributed from router to router. There is a capability of doing this if you want to with extended BGP communities, but that's making things way more complicated than they need to be. And I'd rather that you try and keep things simple and deploy on eBGP speaking routers only. If you have a default route in your network, there's still some value in implementing ROV. Invalid routes are not in the internal table. You rely instead on default to the upstream provider who's also going to do this. So summary of this, AS operators really should consider, must consider deploying, so getting your row assigned and dropping invalids. It's an important step to securing the routing system, the global routing system. It's a step, it's not the end goal. We have a lot more work to do, but this will at least let us start the path to securing the global routing system. Once we have origin validation in place globally, opportunities for malicious or accidental misoriginating are considerably reduced. I'm going to show you a couple of slides from the NIST RPKI monitor, which is really useful, informative site to have a look at. If you want to read more about RPKI, there are many FAQs there. I've used the NLNet Labs one for quite a few years now when referring people to how this is all working. So here's some pictures from NIST. This is the version 2 of it. And so the first graph is really showing on their BGP feed the number of not founds versus the valids versus the invalids. So about 962,000 prefix origin pairs they see. So the 25 autonomous systems with the most BGP originated prefix is valid. So the most valid is right there at the top of the list. TTNet AS 47331. Amazon next, and if you look very, very carefully, you'll see there's a tiny little yellow. So there must be a prefix or few that are still listed as not found. And so on we go through the list. Viasat, TTNets, other AS, Telefonica in Peru, Bezek in Israel, and then we carry on down the list. And so those are the top 25 with the most BGP originated valid prefixes. The next one shows with the most invalid. The first one's kind of interesting because I do my own routing analysis of the BGP system and have done since 1999. And I do not see AS23456. That's a configuration mistake because that's the transition autonomous system from the old 16-bit AS numbers to the current 32 bits. So somebody somewhere is obviously using AS23456 to originate stuff. And I would be very suspicious of anything coming from there. And you can see the large number of invalids. Quite rightly so. Comcast, large number of invalids also. Vodafone in India. And again, down the list, the number of invalids we're seeing from these places. Now, any operator who's dropping invalids will not see these prefixes. So all these operators have no connectivity through networks or to networks that are dropping invalids. I wonder if they realize, I wonder if they even know that this is what's happening. What's the other one I've got? Okay, the 25 autonomous systems with the most address space valid. So Comcast at the top, then Microsoft. Microsoft is all green, as are Amazon, all green. So pretty much everything there has that they have as being marked as valid. And again, the top 25. So you can keep an eye on the NIST monitor. It's quite an interesting page as they improve. There's a lot more than I just showed you here. You can, various menus and graphs and so on that you can have a look and see what the status is. If you want to know a lot more about some of the fundamentals and how to configure a lot of this, NSRC has video-based education at learn.nsrc.org. It's not meant to be an advert for NSRC. It's meant to be showing you the resources online available if you want to learn more than you can in this 20 minutes quick presentation from me. You can find more about routing security, RPKI, as well as a whole lot of other topics as well. Acknowledgements, we have to thank the National Science Foundation for promoting good routing security via the International Research Network Connections Program and the work of the NSRC. And of course, the Internet Society. We are partnering with Internet Society in the global efforts towards improving routing security. And that is all I have. Happy to take any questions if there's still time to do that.
Thank you, Philip. Are there any questions? Okay, they're just acknowledgements and thank yous. There's a thank you from Pinda Wong saying, thanks, Philip, great RPKI talk. Had to distill this in the time that you had. Clear.
Yes, 20 minutes is a bit of a challenge, but I hope that everybody listening managed to get something out of it. Feel free to get in touch with me offline if you have any questions or any clarifications are needed.
Right. So if there are no questions at the moment, Philip is open to questions after this. Otherwise, thank you so much. Thank you, Philip. It's good seeing you after a very long time.
Hello.
And have a good AFNOG day.
Hello.
Thank you, Isabella.
Hello.
Oh, yes, there's a question. Yeah, yes.
Hello. Can you hear me?
Yes, yes.
Okay. No, I think we can't let Philip go like that. I think we need to push at least a question. So Philip's good. This is Alain speaking. Good presentations, and yeah, I want to know your thought about, I'm sure you knew at the beginning when we were doing this RPKI, and still now there are some discussions. This is just a waste of time. It's going nowhere. This is based on the PKI, and the PKI take you nowhere, etc. So how do you now see from that day to now the adoption rate we are seeing in terms of the AS signing the ROAM? So what do you think have been the motivations for this kind of adoptions? Because it was not obvious from the beginning.
Yeah, I mean, I think 2 years ago, Alain, I was kind of wondering if this was actually going to go anywhere because the uptake was really, really slow. But, I think there's been a bit of focus. The Mozilla Foundation funded a project in South Asia to drive RPKI adoption there. And that's, a colleague, Mohammed Abdul Awal, drove that one all last year, 2019 and last year, with, quite an amazing success in that, he contacted every single operator almost through the whole of South Asia trying to make a difference. And I think it's individual efforts like that that is actually making some kind of difference. People will wring their hands at the latest DOS attack or the latest hijack and so on. And then when they realize that, oh, well, if I actually signed some ROAs and I paid attention to the invalids out there and I actually did ROV, it actually might make a bit of a difference. And I think once people have understood it, in amongst, very, very busy lives, dealing with the pandemic last year and now is taking a lot of people's time as well. And So trying to get all that fitted in, it's been challenging. So it's actually the last 18 months, I think, has been quite incredible. Just, looking at even some of the NIST graphs, how they've just gone upwards. It gives me a lot of hope that we're, finally, going to make a big difference globally for this.
I think that was amazing. Okay, so there's a thank you here also from Logan Madden. And say thank you, Philip. There's a one about invalid prefixes. I don't know where that feedback is coming from.
Philip, can you hear me?
Yes.
So it's more of a comment. There are some operators who are worried about the possibility of losing traffic from invalid prefixes, and some operators are concerned that we shouldn't drop invalid prefixes by default. I'd just like to comment that Telia did that, and there were not that much issue on their side when Telia decided to drop invalid prefixes by default. Thank you again.
And that's why I think the observing part is actually very important. Just plunging straight in and doing validation. I've helped networks probably 6-7 years ago who just dived straight in to do validation, and there were connectivity issues and so forth. People didn't understand what was going on. So it's actually very important to hook your routers up to a validator, but don't discard anything until you get a good understanding about what some of the issues might be. So certainly spending a bit of time and observing would be it's a very sensible move.
Okay. Philip, there is a question here from Pindar. He says, any advice, WRT, best common practice on key rotation? Also, Honlu Musa says he can't access the link. The RPKI monitor -V2.
So what's happened so I'll go to the link first. What's happened there is I updated the slides this morning. The link worked 2 days ago. So I think NIST, they've removed the -V2. So if you just do rpki-monitor.antd.nist.gov, it works fine. They must have changed it because it was a pilot of the V2 monitor, which they published as, hey, this is the new monitor. And they seem to have changed the URL back to what the previous one was. Yes, that's it. Let's just be posted in the chat. With Pinda, with key rotation isn't applicable to here. At least anything like that happens way behind the scenes. From an operator's point of view, just signing a roar, you sign the roar. That's it, it's done.
Okay. Thank you so much. I think we've run out of time. I'd like to say thank you so much. And if you'd like to contact Philip, he's available. I think he's still going to be around for the rest of the day, so you can easily access if you need any more information. I think I'll now hand over to Magali